To capture this live coral cover, let's look at it as an example of work done by Huang 2000 et al. 2019, carried out at Lin Chu Fringing Reef in northern South China Sea. They captured live coral cover using a number of methods. Most especially, they use the subsurface reflectance value. They derive some that can capture the subsurface reflectance value, so that they are now able to map out areas that have live coral covers and areas that do not have such. So they use these to fill in the gaps of missing data and missing data for historical database that has been established over the years. So in this part of the country, they have data that were gathered from field studies on the health of the coral reef around this particular area in South China Sea. So a little bit on Phrygian reef. Phrygian reefs are reefs that are sea level flat kind of reef that grows from the side of either the continent or the particular land area. They grow at the level of the sea surface, the sea bottom surface, and they extend from the mainland into the sea. So they are on the fringe of the land area bordering the sea. So they use different band combination to kind of map out areas that have live coral cover, and they use these to kind of fill in the gaps and create a trajectory of either degradation or restoration. Because now, if we have maps showing where things used to be, in this case now we're talking about live coral cover, where coral cover used to be and where they presently are no more, then they use that to create a kind of trajectory of going to the future. If this trend continues, these are places that are likely to still have live coral cover going into the future, and these are places that will continue to witness degradation. So they use their method to fill in the gaps and also create a kind of possibility to look into the future and see where are things heading. So they use Landsat imagery to carry out this work. So this is just an example of how remote sensing can be used to capture live coral cover and give an indication of coral reef health. Based on we know that coral reef are very important for the marine ecosystem. So going forward, there's an increasing possibility that with machine learning and artificial intelligence being developed more and more, some new methods are being developed that are able to capture more and more details, extract more and more details from remotely sensed information to capture coral reef health. And I think the possibility will continue to grow. So where do we see things moving on from here? The future continues to be very bright in kinds of application of remote sensing for environment management, either marine ecosystem or inland water bodies and so on. There is a whole lot of new development coming through. But if we look at what we have right now, we realize that if we are looking at doing capturing something in terms of remote emergency response, there are examples of tools or sensors that are available around this scope now. So if we're looking at sub 1 meter resolution, spatial resolution, we have this Worldview 2, Panchromatic, Quick Bird, Sonar, Iconos. So all these are useful for emergency response operations. And when we are looking at mangrove and salt marsh vegetation mapping, we have a range of tools that are useful up to around 100 meters for Landsat and Aster. So when we are thinking of bathymetry, we can use from sub 50 meters, 50 centimeters down to around 10 meters to 30 meters data set, spatial resolution. So remember, on this axis we have the spatial resolution, and on this axis we have the temporal resolution. So depending on what we need, there are some tools, there are some things that we need we may not necessarily have daily data, but if we have, for example, around here we have about 16-day revisit time, we could use tools, we could use any of the sensors that has kind of 16-day revisit or 8-day revisit or 4-day revisit to kind of measure, monitor seagrass habitats, their scale and their extent. And when it comes to ocean water quality monitoring, we could be looking, we might not necessarily want something in sub 100 meters and things like that. We might be looking at from around 200 meters down to 1 kilometers, 2 kilometers, 5 kilometers data set, because you have to look at the scale of the area that you are going to be monitoring. That will also determine also how frequently, what the spatial resolution might be, because the larger the area, the greater the amount of data that is generated if the resolution also becomes higher and higher. Remember, this is higher resolution, this is lower resolution, and this is lower spatial temporal resolution, and this is higher temporal resolution. So depending on what is the need is for, so as the direction of this goes, final spatial resolution and final temporal resolution, we need different kind of tools and sensors to carry out those operations. More and more satellites and sensors are being launched into space as the world becomes more and more conversant with the impact of human being on this planet. There is more and more need to study the planet at the global scale, at the planetary scale, so that we see how action from different part of the country, different part of the world impact the environment. So this brings us to the end of this third session and the last session. From these, we have looked at sea level rise and coastal flooding, and we know that we can monitor sea level from remotely sensed data. If we combine remotely sensed data and models, we can produce an understanding of how effective our current actions are in terms of climate change intervention. It can give us an idea of how well we are doing in terms of our climate risk, and also give us an idea of our climate risk assessment. Coral reef health can be monitored with and prognosis can be made using remote sensing, and there are more and more possibility as we go on with new sensors being launched and increasing body of knowledge and computing capacity. There is going to be more and more opportunity to use remote sensing for water resource management. So this brings us to the end of the last session in the applications of remote sensing for water resource management. See you in the next topic.